Hello, I will show you how to solve and find the determinant of a matrix. Let's imagine they want us to find the determinant of this black matrix. So first, try to imagine that there is another matrix 1, 0, 0, 1, and this matrix is describing two vectors. Um, each column describes one vector, so I will draw these vectors. The first vector is the 1 in x, 0 in y, so this is x, this is y. So 1 in x, 0 in y, so this means that there is a vector going from the origin 0, 0 to 1 in x and 0, 0 in y, and this is 1 in x. And the other column is describing another vector that goes from 0 in y, 0 in x, sorry, to 1 in y. So there is another vector going from the origin to that point. If we close this shape like this and we calculate this area, we will see this area is 1 by 1 equals 1 unit squared. Okay, so now let's try to imagine that this matrix they want us to solve was in the past this other matrix, but somehow it got converted into this that I'm going to draw right now. Okay, so now we have to have in the x-axis some marks. So the first column describes a vector 3, 2. This means that it goes from 0, so from 3 in the x position to 2 in the y position. So it describes a vector that goes from the origin to this point. And the other column describes a vector that goes from 1 in x to 4 in y. So basically it's a point somewhere here. So it's a vector that goes from the origin to this point. Okay. So if we close the shape as we did with the other matrix with parallel lines, we'll find something like this. Right? So this line has to be parallel to this one, and this one has to be parallel to this one. If we calculate the area of this new shape, for this case, it's a 10. I'll show you in a minute how I got that. But basically, this means that the determinant of a matrix is a number that, like in this case 10, that is telling us that the matrix we have right now is, for example in this case, 10 times larger than a unit matrix. A matrix that describes a 1 by 1 vector configuration. The determinant could be 10, could be 0, could be 0.5. This will just show us how larger, smaller, or it is compared to a 1 by 1 matrix. Okay, so how do we calculate this? So in this case, the 2 by 2 matrix is very easy. 3, 2, 1, 4. We will just perform some cross multiplication and then subtraction. For example, we will do something like 3 times 4 minus 1 times 2 and this is 12 minus 2, and this is equal to 10. So that's how we calculate it. If the matrix is larger, let's say a 3 by 3 matrix, then the procedure is a little different. You will, let's say you have some numbers here, 3, 2, 2, 1, 3, 4, and 5, 2, 1. There is another procedure in which we can, for example, copy these first two lines here, 3, 2, 2, 1, 3, 4, and then we will do some multiplications. Oops. Multiplications here, and then in this other direction, and we will get all the blues and sum them, and all the reds and sum them also, and then we will subtract one from the other, and then this will give us the determinant. But I will try to explain to you this in another video, but the important thing with this one is that you understand that the determinant is just a number that tells us how larger or smaller the new shape is compared to a 1 by 1 figure. When we talk about, let's say this case, 3 by 3, then we just don't have to picture a square like this. We have to picture now a cube. So now we are not talking about area, we are talking about volume. So we could say that the new matrix has some larger or smaller volume than, for example, 1 0 1 0 0 0 1, than a 1 by 1 cube, which is described by this new 3 by 3 matrix. And the larger it gets, it just shows us many more dimensions. It's a little difficult to draw that because it's difficult to draw a 4-dimensional figure, but the concept is the same. It will just tell us how bigger it is compared to a unit matrix. So I hope this made it a little clear for you, and it will help you in the future to understand what are you talking about when you talk about the determinant. Okay, thank you.